Hi all, sorry I can't be here today. So I'm coming to you in a video to help explain how to solve a nonlinear inequality and also how to solve a rational inequality, which is going to be the second video today. So let's take a look at a nonlinear inequality. Yesterday I had you write down the steps for solving these. So today in this video we're actually going to take those steps and we're going to use them to solve. So step number one was to write the inequality in standard form and then solve the related equation. Okay, so standard form means to move all terms to one side and then go ahead and solve it like it was an equation. So we have three ways of solving. The first way is to use the zero factor theorem, and that's my preferred method if we can factor a polynomial. So in this case there are factors of -10 that add to -3, so I'm going to go ahead and factor, and I get a -5 and a +2. Okay, so when they say solve the related equation, basically they're saying find the x-intercepts by setting these factors equal to 0 and solving. So I've got x minus 5 equals 0, x plus 2 equals 0, so the values that I get for x are 5 and -2. So here is my related solutions to my equation. So then it says to find on your number line, locate these values on your number line. Alright, so I have them on my number line, which is really my x-axis for my graph. And I'm going to draw a little picture of this graph up here. If I was going to draw this graph, these values here would be my x-intercepts, as we discussed last week. And if I draw my graph, it's going to be a parabola that's going to kind of look like this. So I'm going to relate the solutions to the inequality to what my graph looks like. The next thing I do is I'm going to take a look at this inequality symbol right there. And it says that my values must be less than 0. They can't equal 0. They have to be less than 0. So I know when I solve the related equation that the 5 and the -2 make this equal to 0. So since I can't have equal to 0, I'm going to put open dots on those. The next thing it says is to choose a test point from each of the regions that your solutions to step 1 broke your graph up into. So it broke my x-axis into 3 regions, and the first region I'm going to pick a -3 as a test point. I'm going to plug it into my polynomial, and I'm going to use this polynomial right here when I plug it in. So if I plug in a -3 in, I get a -3 minus 5 times -3 plus 2 is less than 0. -3 minus 5 is -8. -3 plus 2 is -1, is less than 0. If I multiply these, I get 8 is less than 0. 8 is not less than 0, so I'm going to mark this section as false. I'm going to plug in a nice easy test point here, which is 0. So when I plug in a 0, I get 0 minus 5 times 0 plus 2. Well, is that less than 0? 0 minus 5 is a -5, 0 plus 2 is 2. 2 times -5 is -10, is less than 0. That is definitely true. And in this last section, I am going to pick 6 and plug that in. I get 6 minus 5 times 6 plus 2 is less than 0. 6 minus 5 is 1. 6 plus 2 is 8. So when I multiply that, 8 is less than 0 is false. Okay, so the only region that is true on this graph is this region right here. And I'm going to write my answer in interval notation. And if I write this in interval notation, I have a -2, all the numbers from -2 to 5. And -2 and 5 are not included, so I put parentheses around them. If they were included, I'd put square brackets. And let's go ahead and relate this to what our graph looks like. When I'm looking for values of a nonlinear polynomial that are less than 0. I'm looking for the x values that make my graph negative. And which part of my graph in this picture has negative y values? It's the part of the graph that's below the x-axis. Okay, this part here has negative y values. It's below the x-axis. If I had an inequality that was looking for y values that were greater, or the parts of my graph that were greater than 0, I'm going to mark those in red. These have y values that are greater than 0. So when you're solving a nonlinear inequality, you're looking for those x values that make your graph negative. And you can clearly see the x values that make my graph negative in my picture are the x values between -2 and 5, because they have associated negative y values. And so we're just looking at the x values, we're looking at the x-axis when we're solving our nonlinear inequality. We don't actually have to graph. Okay, so write that example down, and we're going to go ahead and work on another one now. So if you need to write it, pause the video, because I'm going to go ahead and erase it. Alright, so the next example that I'm going to do is going to be one that is not factored. So I'm going to write this, and we're going to look for values of this polynomial that are less than 0. So the very first thing I need to do is I need to solve my related equation. So I'm going to go ahead and factor this polynomial into x times x minus 4, because we always look at taking a GCF out first. Then I'm going to take those solutions, set each one of these equal to 0, and solve. So I get two values of x that make this related equation equal to 0. I get 0 and 4. I'm going to take my x-axis and locate 0 and 4 on my x-axis. And I want you to notice that my inequality sign this time, it has an equal sign. So it's allowed to equal 0. So instead of writing open dots, I'm going to write closed dots to remind me these can be part of my solution. So now I'm going to plug in test points. I'm going to plug in a -1 into this region, and I'm going to use this polynomial right here. -1 times -1 minus 4. I'm going to test to see if it's less than 0. -1 minus 4 is a -5. -1 times a -5 is a +5. So that makes this false. Let's go ahead and choose a test point here. I'm going to choose an easy one. I'll do 1. So I have 1 times 1 minus 4 is less than 0. 1 times a -3, which is a -3 less than or equal to 0. Yeah, -3 is less than or equal to 0, so this region's true. I'm going to choose a test point from this region, and I get 5 times 5 minus 4. I'm going to see if it's less than or equal to 0. 5 times 1 is less than or equal to 0. 5 is less than or equal to 0. That is false. So the only region that has true is the middle region. I'm going to write that in interval notation. Oops, in black, not yellow. I have a 0 and a 4. Since my endpoints have solid dots, I'm going to put square brackets on them. Alright, I'm going to do one more example. So if you need this, pause it and write it down, because I'm going to erase it. Okay, last example. In this example, we are going to have 3 factors instead of just 2. Okay, so let's go ahead and solve this related equation or inequality. So I have 3 factors that I need to set equal to 0 to solve the related equation. Alright, so the values I get here are x equals -2, 1, and a +5. So my next step is to draw my x-axis and locate all of those points on my x-axis. Alright, so I want you to notice that my inequality includes an equal sign, so it can equal 0. So each one of these are allowed to be part of the solution. So I'm going to put open or closed dots on each one of these. Now test points. Let's go ahead and pick test points and plug them in and see what happens. I'm going to use -3 in the leftmost region. So I get -3 plus 2 times -3 minus 1 times -3 minus 5 is less than or equal to 0. Here I get a -1, here I get a -4, and then a -8. So let's see, I have negative times a negative, that gives me a +4. And then 4 times -8 is a -32. Alright, -32 is less than or equal to 0, so I'm going to put a true in this region. I'm going to pick a 0 from the next region. That's always an easy one to pick. So 0 plus 2, 0 minus 1, and 0 minus 5 less than or equal to 0. And I get a 2 times a -1 times a -5 is less than or equal to 0. -2 times -5 is less than or equal to 0. I get 10 is less than or equal to 0. That is false. Let's pick one from this middle region right here. Let's pick 2. I'm going to work above my line this time. 2 plus 2, 2 minus 1, 2 minus 5 is less than or equal to 0. I get a 4 times 1 times a -3. That gives me a -12. Is -12 less than or equal to 0? It is. I'll mark this region true. And my last test point, I'll pick a 6. Okay, so 6 plus 2, 6 minus 1, and 6 minus 5. We're testing to see if it's less than 0. So we get an 8, a 5, and a 1, which gives me 40 is less than or equal to 0. That's false. Okay, so I'm going to pick the regions that have true as the answer. I've got this region here and this region here. I'm going to write my answer in interval notation. So in my first region, this really goes to a -infinity. So I have a -infinity to a -2. We always put parentheses around my -infinity side. Since I have a closed dot, I put a square bracket, and since I have 2 regions, I have to join them with a U for union. My second region is from 1 to 5. They both have closed dots, so they both get square brackets. And my final answer is that. And this video is done, so now I want you to move on to the video for solving rational inequalities.